Welcome to our class today. We'll be looking at on-chain verification of Noir proofs using smart contracts. It's just a continuation of our classes. We've been doing our writing circuits in Noir. So after we've come up with the verify.sol, which we said is our contract, we now want to deploy it and then verify on-chain. Now, but today's class, of course, we just doing it locally using Anvil, deploy using Anvil, and then do verification. And then the lesson after that, we will now carry the same concept to testnet and see how to do this, how to do deployment and, of course, verification on testnet. Now, so what are our objectives in our today's lesson? Of course, we've said up to this level, we know how to write Noir circuit and then generate verify.sol. So that is where we then begin from to understand the role of this verify.sol contract in a zero-knowledge proof verification. And then from that, explore the structure of the Foundry project and locate relevant files. Relevant files here, it means verify.sol. It also means the .sols, all the .sols, including CPN verifier app.sol and so on. So that what that means is you've written this circuit, and can you locate these files on your project? That's what we are doing. So if you don't have these files, then can you then write them? Now we'll learn how to inspect contract names and confirm the verifier contract. Inside this verified.sol, can you find the contract? Can you confirm what is a contract here? Then we will prepare the verifier contract for deployment and testing, proofs, and public inputs. And then lastly, we build confidence in verifying proofs, both in tests and on-chain. So what will be our outcomes after this class? After this class, the outcome will be one, we'll want to successfully compile a project with the Foundry. That is a Forge build. We'll also have deployed verify.sol locally on Anvil, and we'll have verified ZK proof using Forge tests, and then direct contract call, and so on. Then lastly, we'll have confirmed the proof verification works, both in Foundry tests and on local chain. So by the end of the lesson, we need to have achieved this. And this is just in addition to the objectives we had. Now, working with the smart contracts, we are already aware of these 2 points. One, we're able to test and verify locally, and also we are able to use Noir to generate verifier contract in Solidity. And this verifier contract is what we'll be deploying on EVM compatible blockchains, such as Ethereum. Now, to begin, let's open our project. I want to open my project, the one we've been working on all along, so that we use it. So I'll just share my project. Okay, this is our ZKP linear check. This is a project we've been working on. So we've already written this, we wrote it in our last class. So just a few things that were not in our last class that we'll be adding on. Just a few things we'll be adding on here. Now, the first thing after you've written a project, you want to do now compile and then write verification key, generate verification key, and then generate solidity verifier. But what we've been doing and what we did in our last class was that, okay, we can do now compile. For us to do now compile for this circuit, we want to get into circuits. To get into circuits. After getting into circuits, you do another compile. We already have targets, but if we do not have targets, another compile will give us that target. Give us target, and then it will give us this dot JSON. It gives us this dot JSON. That is what Nago compile gives us. But you can see the proof and the public input. And this means I already generated the proof. I already generated the proof and so on. And of course, we did that in our last lesson. That is when we generated the proof. Now, so we require verification key, as you can see here. Verification key required to generate it. And in our last class, we automated that process. We even automated the process of Nago compile and put it in a script, build.sh. So that is where we compile, and then after that, generate a verification key. Again, it will be automated. Of course, if you don't want to automate, then you could use this command directly. After that, we generate verified sol or contract, and this is the command. And again, this has been automated. And if you don't want to automate, you can still use this command as it is here. Okay. Now, so let's just run our build.sh as we've always done. Build.sh. And when you run it, it compiles, it does now compile. Then after that, generates verification key and it stores that generation key, no verification key as VK inside the target. And then it generates solidity verifier contracts and saves that inside contracts as verified sol. So it's here, verified sol. These are contracts. Okay. Now, so you have the verification key. That is it. That is it. If you wanted to generate the proof, and of course we did that last class, but just to remind you, you get out of this, get out of circuits and get inside JS. Then inside JS, you would run yarn generate proof. Yarn generate proof. And you can see the proof has been generated successfully. The proof has been generated successfully. Now, most of these commands I've put them inside I'll put them inside this README. Most of them are here. Most of the commands I'm going to use, and even the ones I'm using currently, are inside here. Okay, so that is okay. Now, so once we've generated the verification key, the proof, and so on, what follows is I want to see whether or inspect our verifier contract. I want to check whether the contract is inside. The contract is inside our verified sol. There's a command I put here. We are going to use that command. Let me just look for it. This command will tell us if there is a contract inside our verified sol. So we will get outside JS. Oh, just a minute. Just a minute. Let's get inside contracts. And then when you run this command, you want to see whether JS has a contract, and it says, after running that command, you can see there's a contract, and this is how it appears. Abstract contract base honk verifier is I something like that. The contract, so contract this is base honk. Contract verifier is base honk, and so on, and then it goes on to give these parameters. Okay, let me just go inside this virtual sol and show you the contract, and that is what it was just telling us. It's a short way of finding out if there's a contract. So just scroll to the bottom. When you scroll to the bottom, and see what is written here. Contract home verifier is best that, and this is what we got when we run that. When we run, is what we got here. This part. This is the contract. So our contract is this part, and the others are just supporting functions. The others are supporting functions. Now, what is important here is to note the name contract is home verifier. Home verifier, therefore, if you are going to deploy, that is the contract we will be deploying, home verifier. Now, for you to deploy, you need to have deployment script. And this is the only new thing, one of the new things I've added to our last code. Our last code, we did not have this. So for you to deploy, you must have the deployment script. Let me share with you the deployment script in my notes. So for us to be able to deploy, you have to create a deployment script, and this is it. Now it's at the upper part. You have to you have the pre-gamma solidity 0.8.13, and that means it will accept this and any other current. We have import scripts, console, and so on. Import on verifier from verify.sol. So our verify.sol, so importing this contract from verify.sol, then contract deployment. Contract deploy script is script function and so on. So this is our deployment script. So inside the contract folder, you create deploy.sol, .d.sol. Okay. So that this is a script we will have. So after that, after you add the script, you then run inside on our terminal. And in our terminal, it can be inside the contract or even this terminal. You run Anvil. You just run Anvil terminal, and then you open a new terminal and run this forge script deployed s.sol, broadcast, and so on. That is a new terminal. So let's just do it stepwise so that you're able to follow. So the deploy script is inside our contract. Now the other thing we'll need to add maybe the .env, and I'll explain why that will be important. And the other thing we will need to add is this verify proof.t.sol. And again, we will explain why that is important. I had added deploy.t.sol is the one I'm looking at. I don't know whether I came back and deleted it because I'm not seeing here. Oh, it's inside the script. It's inside the script. So inside the contract, we have this script, and inside the script we have deploy.s.sol. This is what I was looking for. Yeah, this is what I shared with you in my slides. Deploy.s.sol. So it's inside the script. So I said while you are on your terminal, could be inside a contract, or even you can get out of contract and do it inside our base terminal. Let me see if I was to run Anvil, what it will ask me. Now, so I've run Anvil, and inside our base terminal, let me just move this up so that you can see clearly what is happening. At the bottom here, you can see available accounts. So this one gives us just free public accounts and private keys. So these ones are known. You cannot use them for deployment. These private keys are known. But when we'll be looking at how to deploy on testnet, that time you'll be using your own private key that is not known. But for this time, we're using this because we want just to deploy locally. So you just take any of these keys, private keys, and use them. So you can see this is already running and listening. It's already running and listening. So that means it's ready for deployment. It's ready for deployment. It's already running and is listening. So you leave it running, then you go and you open another terminal. You just open another terminal, and so I'll open another terminal in the WSL. And then I'll share just a minute. I'm looking at now let me stop sharing this and then now share the new terminal that I've just opened. And this is a new terminal. Of course, you can see it's still the same ZKP, linear check, and so on. So I want to get into contracts. Then after getting into contracts, this is the command, forge script, deploy, and so on. So it tells me that a forge is not found. There's no problem. I will come back to that command. But what that means is that we have to install forge, or that forge is not in the right path. Forge is on the right path. So for us to ensure that our forge is in the right path, I'll use this command, curl, this command. I'm still inside contract. I'm still inside contract. So I just want to ensure that forge is in the right path. Okay, so that is the command that, so when you run it, just press enter. It has detected our preferred shell as bash, and then added the phone root to path. So it says run source home, that, and so on, or start a new terminal, and so on. So we will run source instead of adding, starting a new terminal. What we will do is we will run source. So it is source bash, because that is our shell that has been detected. So we just run it here. Source. This is the command. Just press enter. Okay. Then after that, it says, then install Foundry. To install Foundry, after that, it just means that we just run Foundry up. So when you just run Foundry up, it installs Foundry. So that means I just run Foundry up and it's installed. Now it's after that that now I come back to the command we had just, our command was here, forge. It was coming up to broadcast. So I just copy this command and run it now. So I pasted the command, then press enter. This time it should be able to now give us the results we want. Okay. So you can see this time there is no, this time there was no warning. Oh, but that's okay. Oh, okay. The problem is here. We're supposed to pick one private key. Supposed to pick one private key from the ones we had produced and put it here. So we did not use a private key. So that is why we are not getting what we expect, because it's supposed to tell us that it has been deployed. Okay, let me see what I had put in my notes. My notes I had said, just for the sake of completion, just to ensure that you have all the notes. We had already said you come here, run Anvil, and then run this forge script that. And this is what we'll just run. Let me just see. This is what we'll just run. Just a few. Okay, we'll just update this command we used. We'll update that. But now the thing is here. The thing is, what I wanted to show is when you get a command that forge is not found, this part we've already dealt with it. In such a case, you do the following. You download the install Foundry using this command. This command downloads and sets Foundry the installer, and then it detects your environment. For our case, it will be detected that we are on bash, and therefore use source bash. then Foundry. If you want, you can check the version and so on. Okay, so let me run the command that is in my notes. The command that is in my notes, the one I include in my notes, is slightly different from the one we just ran. Okay, that's the command. Slightly different from the one we used. The only part that is different is that I've included this part and so on. So let's just try to press enter and see what happens. Yeah, this one was successfully, it has run, but now it's telling us that the verifier has been deployed at this, then it's telling us the only error is saying that you seem to be using Foundry's default sender. Be sure to set your own sender. That is why I was saying that at that point, you need to use the exact key. You just pick one key and use it. But you can see that it was actually deployed. It was actually deployed. So let's pick one key. Let's just go back and see what keys we have. What keys we have, not this one. We had some keys. Yeah, this is the one I'm talking about. The private keys are here. So you can just pick even this first key and use it. Okay, so thank you. That was I to share. I was to share. I think it's this one. Yes, it's this one. So we're just to change and have a key. So you can see how we replaced a key here instead of what we had previously. So let's just try to press enter and see what happens. Let's broadcast. Good. So I've used, so you can see this one has now been deployed successfully. And say success. There's even a hash and there's contract address. There's paid if. And remember, we are doing this free. We are doing this on our local machines. It's the same process. We just make a few changes and then do it on chain. So just the same process, just a few changes here and there. But we are able to deploy. We just deployed a contract on our local machine. And you can see it has been successful. So when you just change the key, private key, and then you use, and of course we say this private key should not use it when you're deploying on testnet. Because this one is public, is in public domain. So you cannot use it when you're doing your own things for production. If you're doing it for production, you don't use what is in public. Okay, so that is what we wanted to deploy. Now, what follows is how do we then verify? After deploying, how do we verify? Now, you remember when we were doing it last time on Remix, we got some problems with the sizes and so on. Some were bigger than required. And so it was not running. That was last time. But I've gone around that by somebody might be wondering what happened because last time we tried to deploy it in Remix and it was not working. So this is how I fixed the contract size. The contract size, because last time it was saying that there was an error. Our contract was at 3111 bytes in size and is greater than what is recommended, which is 24576. So for me to go around this, I just edited the foundry.toml and then included optimizer 200 and then did that. Yeah, that's what I did. Just that's the only thing I did on my foundry terminal. So my foundry terminal, therefore, currently is this way. So this optimizer runs 200 optimizer is true is what makes those what makes the difference. That is where the difference is. Now, if you want to know whether it's what our size is, you can run forge build sizes. Let me just again share this. I show you. You can always know which one is bigger or what sizes are they. So if you come back here and then write forge build sizes. Now, this is what was bigger that last time. This is what was bigger last time. This is what was bigger last time. What happened is that let me show you how my foundry.toml is. My foundry.toml. Foundry.toml is supposed to be inside contracts. Looking for it. Oh, is here. So what I'm saying, I added this part. So if I delete this part, let me just delete this part. Delete this part. Let's go back and see what the sizes would be. Now these are the sizes. Look what this home verifier. Now I've just deleted that part. Let's try again, forge build sizes. And you look what home verifier. Now look what it's now back at 30, 11, 11, and this is the problem we had last time. So this problem, it means if you try to compile, to deploy, it will not. Okay, it will tell you that the sizes are bigger. Let's just try and see. This was our command. This was our command up to here. Let's come back here and see whether it will work, whether it will be deployed with that size. It says some contract exceed the runtime limit. Some contracts exceed the runtime limit, which is 24,576. And of course, that contract is this home verifier. It exceeds that limit. So for us to go about that, we go back to our our foundry.toml and return the modification I put there, the one we just deleted. So I've returned it. Since I've returned it, let me now come back and see and again run the same command. The same command is still here. Just returned what we have deleted from foundry.toml. Now again, I did not run it properly. I don't know why it's okay. Let's do forge clean. Why is it? Okay. I don't know why it's jumping like that. The command is this. This is the command. Then run it. Okay, so I don't understand why. Unexpected token. Or is it because did the anvil stop? Let's just check. Okay, so maybe we can stop this anvil. Can stop this and then begin afresh. Okay, so I'll just stop it. Okay, let me now again run anvil. Okay, now let's come back. We stopped anvil and began it afresh. Then I come here and I think there's something I'm not getting. Why this one is jumping to the next line? Am I using a wrong command? Okay, I've just acquired the correct command. Let us again use it. Yeah, this is the right command. Yeah, you can see again it has worked. So the thing was the size of the contract. For it to go around that, we had to do some modification to our foundry.toml. That is why we are able to deploy this contract. So after deploying it, you may want to verify and so on. Again, let me just, for the sake of completeness, again share my notes on how to verify. Then we'll go straight and verify. So to verify on-chain, next steps is to verify on-chain. Verify the contract works on-chain. So that is what we'll be doing. So you call the home verifier verify from Forge test or Node.js or Stars.js. So you check the deployed contract. So this is what we run. We run this command forge inspect home verifier. And of course, you must have written the verifier script must have written the verify script for you to be able to do this. So the verifier script is here. It's inside the test contract and then test verify proof.t.sol. So this is, you must be having this. You must include, this one you include the public inputs, declare how many they are. Like in our case, you can see that we have 4 public inputs. We have declared the 4 here. So you can see this is where we declare the 4 public inputs. So this is test verify proof.t.sol. Okay, before we run this test, forge test, let's try to run this other one, forge inspect home verify. Okay, so we're inside the contracts. Let me paste that command, forge inspect home verify. And you can see what we have. It has given us that we have verify byte that, view return, and so on. So this one is telling us that our contract is deployed and can be verified. Our contract is deployed and therefore can be verified. So that is what it is telling us. Just before verifying it, I want to show you the verifier.t.sol. We say it is inside contract, and then inside contract there's this test. Remember, our test initially just had the starter.t.sol. This is what we've been having all this time. But now we've added another folder for verification on chain, and it's verify proof.t.sol. And that's what I'm saying. This is you have to declare how many public inputs are, and then put them here, the public inputs. Like for our case, you have 3, you have 4, you have 5, and you have 25. Now, if you don't know where we're getting this from, you're getting this from after generating the proof, we have the public inputs here. The public inputs in hex. So you can see the first one is 3, and then we have 5, 4. This one is 4. This one are hex decimal numbers. And this one is 5. And then we have, lastly, we have the other. So there are 4 of them. So that is why you get the public inputs. Because you'll be wondering, where are we getting this from? They're coming from after generating the proof. You have the public inputs here. So just come and copy them. Now, so we want to verify our proof, our contract on chain. That's what we want. So we said we would use forge tests, fork, URL. So let's just let me share. That's not this one. Okay, so inside contracts here, let me just paste. Oh, it required me to supply the URL. Just a minute. Okay, so now what about if we leave the URL out of this and just say forge test? Okay, so I'm looking at the error. Just understand what it's telling us. Okay, what I'm saying is that I'm saying like the verify proof.t.sol verify proof test failed. It reverted because the input, or the proof that was passed was not correct, was not valid. So I think this is as a result of what we were trying last. We were trying to, when we did change our uh, phone.toml, it had some impact on this. So I think that is where the error is coming from. When we did change our uh, uh, phone.toml and we did not begin the anvil afresh. So then what we deployed had a wrong length. The proof had that contract had wrong length as compared to the one in the proof. So I think that is where the problem was. So that means for us to cure that, we need to begin the anvil afresh and then deploy afresh, then verify afresh. You remember when you were trying to change the anvil, that toml, foundry toml, I was showing you that if it remains as it was, we will have the home verifier, which is longer than what is required, 24,000 and so on. It will give us 30,000 and so on. So that is when we did deploy with that, and that is when we got the wrong length. That is what it's now telling us about the wrong length. You can see it's talking about 38 and 6. And that is the value we're getting when we changed our, so approximately this is when we did it, and when we did change our phone return. But with the correct phone return, we were getting the length was what is required, smaller. And so this is just as a result of that. So for you to cure that, you go back from the start, return the phone return as it were, and then do unveil, do deployment, and come to verification. And when you verify, you get your results correct. Okay, thank you. That is all I wanted us to learn today, how to deploy our verified solve that we've written in using Noir circuit, how to deploy it on our local machine, on Anvil, and then verify. So we'll then be extending the same knowledge on how to deploy it to testnet Seponia. So that's what we'll be doing in our next class. Thank you.